Hello everybody, this is another presentation on systems of simultaneous equations. Now it again focuses on 2F, so I'm hoping you'll have a look through these and find all these presentations useful. Now we have a system of simultaneous equations here. Let's call this one equation 1 and this equation 2. Now what we want to do is to find the value or values of k if there is no solution. So what we're going to do with question 1 and question 2 is to find the gradient and y-intercept of each. So I need to get the y on its own. So what I'll do is I'll rewrite this equation and I'll take the minus 2y across to the other side and the 11 minus k across to the other side. So we could then say 2y is equal to k minus 1x plus k minus 11, and I'll divide by 2 on both sides. So that end up with y equals k minus 1 over 2x plus k minus 11 over 2. So the gradient for equation 1 is k over 2 minus 1, and C1, the first y-intercept will be k minus 11 over 2. Now for equation number 2, what I'll do is I'll take this 3 minus x across to the other side. That way I'll end up with k minus 2y is equal to 3x minus k plus 3. And then I'll divide on both sides by k minus 2. Now that way the k's will cancel, these will cancel out and just leave me with y. So I'll have y is equal to 3 k over 2x minus k plus 3 over k minus 2. So that will mean the gradient is equal to 3 over k minus 2, and the second y-intercept is minus k plus 3 over k minus 2. Now, if we want to find where there is no solution, it would be where these two lines are parallel. So that means that gradient must be equal to that gradient. Alrighty, let's have another page and see what happens next. So what I've done here is for the gradient and the y-intercept, I've said, well, the gradient of one line, what if we make it equal to the gradient of the other line? And the y-intercept for one line, what about we make it equal to the gradient or the y-intercept of the other line? And let's figure out what values of k we have here. So in order to solve this first equation here, let me cross multiply. So I'll end up with k minus 1, k minus 2 is equal to 6. And then I'll expand this side, so I'll end up with k squared minus 3k plus 2 is equal to 6. Then if I minus 6 from both sides, I'll get k squared minus 3k minus 4, and that's all equal to 0. And I can factorize this side, so I'll go k minus 4, k plus 1. So that would mean k was equal to 4, or k was equal to minus 1. So the two lines we had before, if k is equal to 4, they're parallel. If k is equal to minus 1, they're parallel. Now let's solve this equation here. Alrighty, again, let's cross multiply to get rid of the fractions. So what we have is k minus 11 times k minus 2, that's equal to minus 2k plus 3. Now if I expand these brackets, that'll be k squared minus 13x, or 13k plus 22 minus 2k minus 6. Now I'm going to get everything across to the other side by plussing 2k there and plussing 6 there. So I'm going to need to keep the equation balanced, so I'll do the same thing on this side. When I do that, I'll get 0 on this side, I'll get k squared. Now minus 13k plus 2k is minus 11k, and 22 plus 6 is 28. Now if I factorise that, I'll get k minus 4, k minus 7. So k can be equal to 4 or k can be equal to 7. Now, what we want to do is to figure out where there is no solution. Now, when k equals 4, or when k equals minus 1, the lines are parallel. But when k equals 4, what we have is the same gradient and the same y-intercept. That would mean there is an infinite number of solutions. So let me write that. When k equals 4, infinite solutions as the gradient and y-int are the same. But when k equals minus 1, the lines are parallel, and therefore no solutions. So the answer is when k equals minus 1. When k equals minus 1, the lines are parallel and they'll have different y-intercepts. Alrighty, Year 12, I hope that helped. I'll see you in class where I can answer any more questions you have. See you then.